And now what people do is they re-optimize their consumption. Some people will switch towards just a few more video rentals and continue to consume movies. Others will abandon movie rentals altogether. But the point here is they're not drawn on the same scale. This year could be $10, this year could be $4. And how big these price spreads here, this could be a quarter, and this year could be 75 cents or something like that. But of course, in the real world, the magnitude of these effects really does matter because that's ultimately what you're after. All right? Thank you. That was a good question. All right, so that's all I'm going to talk about for general equilibrium. If you want to learn more general equilibrium, come join us in graduate school. I promise you 5 years of misery at a really low wage, where at the end you get to become an assistant professor and be miserable for another 6 years at a really low wage. So, no, I'm joking. Being an assistant professor is a privilege. But I'm glad it's over. Okay, this is the part. If you have a 5-year-old, building stuff is really fun, but what's the best part about building stuff? You have to smash it apart, right? So watching stuff fail, or if you're more literary inclined, there's in Germany it was called Alexis Sorbas. I think here it's called Zorba the Greek, maybe. It's a great book about where in the end everything falls apart. So watching stuff fall apart can be a satisfying exercise. What we're doing here is we're going to look at. May I say that? I don't know if that's appropriate. Maybe not. When you're unsure about whether something's appropriate or not, don't say it. That's a really good rule to live by. So the most important of all market failures, I think, is the monopolist. Why is the monopolist the most important of all market failures? Because it's the most clear-cut, easy way to understand what a market failure means and how it's different from a prediction from the perfectly competitive model. That didn't come out as clearly as I wanted to. Let me try again. The perfectly competitive model predicted that firms and consumers left alone will choose quantities and settle at a price that maximizes welfare. You can't make welfare any bigger than letting consumers and firms choose the optimal quantity and price in a market. Right? World left alone maximizes welfare. What a market failure means is that consumers and firms left alone will not choose quantities and prices that maximize societal welfare. The market fails to attain the welfare maximizing output price combination. All right? What this says is in a world of market failures where markets fail to reach the welfare maximizing price output combination, what we want to do as people who strive to make the world a better place is move this market towards a price-quantity combination that actually maximizes social welfare. So what we're going to do now for the rest of this class, essentially, is studying different types of market failures where leaving these markets alone will get us to a point where we could do better, and then study ways of making these societies better off. Right? So the pattern we will follow is I will show you a market failure. I will tell you why and how the market fails. So what price-quantity combination will these firms choose if left alone? Then I will point out the socially optimal price-quantity combination, and then I will point out how to get us from the suboptimal point to the optimal point. So same pattern for all of these market failures. So we're going to start with Monopoly. Monopoly is the greatest board game of all time. I own 4 versions of it, just in case one doesn't work. But it is also a setting where there's only one supplier of a good with no close substitute. Right? Am I a monopolist? No way. Right? There are intermediate microeconomics instructors on this campus who are way better than I am. Marty Only, come on. The woman is a legend. She's amazing. So while I am the only person teaching IAS 106, it's my class. You can't have it. There are lots of close substitutes for this class on campus. You may disagree, you may not disagree. That depends. But the point here is a monopolist really is a good where there's only one firm producing it and there's no close substitute for it. So one example which is imperfect, but I think rings true with most of you, and since I'm so out of touch with reality, I have a struggle coming up with a better one. But for example, for a long time, a company called Microsoft was pretty much a monopolist in office computer operating systems. Everybody used Windows, right? It was everywhere. That's no longer true, especially in academia. OS X has just skyrocketed. But for a while, Microsoft was the only company that produced operating systems for office computers that most offices would use. Were there close substitutes? Not really, especially if you wanted to play with those other computers, right? So it's an imperfect example because there were substitutes and we'd have to have a lengthy argument about why, what does a close substitute mean? But just imagine an imaginary monopolist who produces one good, there's no close substitute. So how about diamonds, right? A diamond is what? Forever? No, I don't believe it. But okay, diamond is forever, right? For a long time, how many firms were in the market of selling diamonds? One firm, right? They didn't even put their brand on diamonds. It was just called a diamond is forever. De Beers. That's different from De Beers, okay? So there was one company that sold diamonds. It's a really interesting case study. In business school, you study it in greater detail. But if you think there are close substitutes for diamonds, try and propose to your partner with a close substitute for a diamond. That's all I'm saying, right? I heard that's true coming out of the front row. But the point here is there may be no close substitutes for diamonds, but there's lots of other examples where there are single producers that produce a good that there's no close substitute for. What this means is that single firm produces the entire market output, right? I don't have to horizontally aggregate supply curves across firms because there's a single producer with a single marginal cost curve that produces the entire market output, right? There's not farmer A, B, C, D, and E. There's only De Beers, and De Beers produces all the diamonds, so what we're going to see is its optimal output quantity is going to depend on its marginal cost curve. Just to make it clear so you don't say anything embarrassing, there is no supply curve for a monopolist. Okay, we can discuss that later, but the monopolist doesn't have a supply curve. It's always a trick question we often ask in qualifying exams for graduate students. Why that is, I'm happy to explain later. So the single firm's output is the entire market output. That also means that single firm faces the entire market demand, right? So for a perfectly competitive firm, what we said is a perfectly competitive firm faces the residual demand curve, which is the price coming out of whatever the market is. So a single firm can sell as much output as it wants, but its output choice does not affect what market price is, right? That was the definition of a perfectly competitive firm. You cannot affect market price. Well, now that the monopolist, the single firm, faces the entire market demand curve, if it sells more, right? If it increases its output, since it faces the market demand curve, all of a sudden price drops, right? Because its output actually affects people's willingness to pay for that particular good, right? So it faces the entire market demand curve. Its output choice the market output only depends on its own marginal cost curve. So the equilibrium quantity sold in this market depends on market demand, and it depends on the monopolist's marginal cost curve. What I'm going to show you, just to give you a little preview, is what the monopolist will do is it will restrict output. It will produce less than the perfectly competitive firm would, and it charges a higher price, right? What it gets in exchange is what we call rents, or captures lots of surplus from consumers. We shall also see that there's a significant amount of deadweight loss from having a monopolist operate in the market. And we can show all of this with the tools we've learned so far, which is pretty cool, I think, right? So if the monopolist raises its price, does it lose all sales? No, right? Then price rises, and since it faces the market demand curve, it'll sell less, but it doesn't lose all sales. If the perfectly competitive firm raises its price above whatever market price is, it all of a sudden sells 0 units, right? Because you can just go to other firms and buy stuff. So it does not lose all sales if price goes up, and it faces this downward sloping demand. We're going to ignore perfectly elastic demand curves because that's a pain in the neck to do. Okay, so what can this firm do? This firm can set price within a reasonable range, right? So if Microsoft charged $500,000 for a copy of Windows, where are we? 8? Windows 8, very few people would buy it. I bet you somebody would buy it, but very few people would buy it. But within the range of $1 to about $500, there's a tremendous amount of room where Microsoft could set the price for Windows 8 and probably still sell some units. So Microsoft's problem is not only how many units to sell, but it also has to figure out what price it wants to charge for those units, all right? So a monopolist, well, we're in Berkeley, right? And monopolists are evil. They're just bad firms, man. They're not. Well, maybe, but the ones I know aren't. All they are is they're profit-maximizing firms, right? They're no different in any observable or unobservable way from a perfectly competitive firms in terms of what they're trying to achieve. All they're trying to do is they're trying to make a buck, right? So, sorry, I'm on fire today. So the monopolist is a regular profit-maximizing firm. There may be some with ulterior motives, but I don't want to talk about those because I'll get myself in trouble. So monopolist is a regular profit-maximizing firm. That means the monopolist maximizes profits just like any other profit-maximizing firm where marginal revenue equals marginal cost, right? Marginal revenue, the number of dollars I get from selling one more unit, is exactly equal to the marginal cost of producing that additional unit. The same rule was true for the perfectly competitive firm. Perfectly competitive firm maximizes profits where marginal revenue equals marginal cost. Only for the perfectly competitive firm, marginal revenue was price, because if it sells one more unit, it gets market price. No matter how much it sells, it does not change that price. For the monopolist, as it sells more units, as he or she sells more units, what will happen is price will change because he or she faces the entire downward sloping demand curve. In case you're worried that this went a little bit fast, I'm going to spend a lot of time on this particular point because it's really hard to grasp. So let's worry about this for a second. Perfectly competitive firm, if it sells one more unit, it gets market price, right? So on average, for each unit sold, it gets market price, right? So it doesn't matter how many units it sells. If it sells one more, it always gets P more dollars. That means on average, it gets P dollars per unit. That means marginal revenue and average revenue for the perfectly competitive firm are exactly equal. They're equal to price. For the monopolist, this is a problem, right? For the monopolist, price is no longer exogenous. Whoa, Max, big word, big word. Exogenous means beyond its control, right? Or given. So for the monopolist, price isn't something that they look up and that's what they're stuck with, but it's something that's going to vary depending on what quantity they sell. So price depends on the quantity produced, and that is under the monopolist's choice. So what this means is that the monopolist has a really hard problem, right? By choosing their output level, what they will do is they will not only choose their output level, but they will also choose their the price they get per unit. So average revenue is price times quantity. That's total revenue divided by quantity. So average revenue is going to be price, which is a function of quantity. For the perfectly competitive firm, price was not a function of quantity. It was just a number, all right? This is going to be a bit of a nightmare. So let's try that, all right? Max, I don't like the word nightmare. Yeah, I don't either. Price, and let's be consistent here, little q, because it's now a firm. You could draw little q or big Q, it doesn't matter because the firm produces market output. Okay, so let's draw a demand curve here. Okay, this is my demand curve. And just to be clear, demand just tells me on the margin how much a consumer is willing to pay for one more unit. Since this is market demand, that's marginal willingness to pay. That's price as a function of quantity. So at this quantity right here, if I go up to my demand curve here, that tells me the price consumers are willing to pay, right? That dictates price. Now, let's think about what happens here in terms of marginal revenue, okay? Marginal revenue is the change in total revenue over the change in quantity. Right? We've discussed this 1,000 times before. If you forgot where this comes from, go back to the lecture where I started talking about profit maximization. So marginal revenue is just the change in total revenue over the change in quantity. Now, if I write out the formula for this thing, it's the change in price times quantity. So that's total revenue over the change in quantity. And that, for those of you who remember the chain rule, if you don't remember the chain rule, don't worry. It's real calculus. That's not calculus light anymore. This turns out P plus change in price over the change in quantity times Q. What just happened, Max? I know. Don't worry. I'll explain it to you graphically. Okay? The marginal revenue is the change in total revenue due to a change in quantity. So let's figure this out. Here we go. I don't know if I can do this. Okay. So this here is 1. This here is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So at one unit sold, price is $8. So if you sell one unit, what's your total revenue? $8, right? It's this area. It's this little rectangle right here. Now, if you sell 2 units, price falls to $7 and you're selling 2 units. What's your total revenue? 2 times 7 is 14, right? You had $8 revenue before, so what did your revenue change by? $6, right? Marginal revenue of selling a second unit means your total revenue goes from $8 to $14. Your marginal revenue is $6. Now, I'm going to show you a way of actually visualizing this on this picture, okay? In terms of area, right, you've got to look at the screen here. The total revenue before was this rectangle right here. Now, the total revenue at 2 units is this rectangle right here. So let me put, what's a sad color? Red, because that's the one that says you're great on the midterm. I'm totally joking. Boo, Max. Okay. I told you I'm on fire today. Let me shade these first. Okay. So the 8-unit rectangle is the total revenue you had at selling 1 unit. The big, going from 0 to 2 up to 7 rectangle is the revenue you had if you sell 2 units, right? It's more. What you do is you gain the blue rectangle right, in terms of new area, but you give up the little rectangle in terms of red area from what you had before. So if you look at the area here, the blue rectangle here, this is 7, this here is 1. So marginal revenue of going from 1 to 2 is 7 minus 1 is 6, right? You look at what you gain, and you subtract from it what you lose. It's $6. Let's do this in another area of the graph and see if marginal revenue is constant in this picture. Okay, which ones did I choose? Let's do this one right here. Oh, not blue. Come on. Cooperate. There we go. Okay, this is 1, 2, 3, 4, 5, 6 units at a price of $3, right? If you go from 6 to 7 units in terms of units sold, price drops to 2, output goes to 7. Right? At 6 units, you got to charge $3 per unit, so you had $18 of revenue. At 7 units, you got to charge $2 per unit, so you have $14 of revenue. What, Max? 3 times 6, 18? Now I've got 2 times 7 is 14. That's a marginal revenue of minus 4, right? So I had 18, now I have 14, marginal revenue is minus 4. Well, the way to show this is simply see graphically what do you lose here, okay? Let's go red. You lose for all the units sold so far, because you charge the same price for each unit, this red area right here, and you gain this blue area right here, right? Red here is 6 times minus 1, so you're losing minus 6. Blue here is you gain 2, so marginal revenue of going from 6 to 7 is minus 6 plus 2 is minus 4. A couple of takeaway points, and then we're going to call it a day, all right? First thing to take away here, marginal revenue is not constant along the demand curve. That means as you go from the top left to the bottom right on this demand curve, your marginal revenue goes from a positive number up here at 6, slowly drops until here it actually goes negative somewhere. So marginal revenue is not the same along the demand curve. That's the first point here. The second point, if you want to relate this to the crazy formula I've put up here, the crazy formula here says marginal revenue is price plus the change in price over the change in quantity, right? So what you've got here times quantity. So what you've got here is P is what you gain. That's the blue area. You sell one more unit, you get P dollars for that additional unit. And the second term tells you for all units sold so far, Q, you lose however much the price drops, right? So this nice formula tells here you gain P dollars, which is the new price, and you lose how much ever the price drops by from that increase in output for all units produced so far. All right? In case you don't like my drawing here, and this happens every year that people get upset by my subpar drawing skills, look at that beauty. This was typeset in PowerPoint 1997, so I should probably make this prettier, but it's in your notes. So it's explained really clearly. What I'm going to pick up with next time here is I'm going to relate this to the demand elasticity. All right? I'm going to show you that halfway between 0 and the point where demand intersects the x-axis is the point where demand elasticity is exactly 1, which means the monopolist will only ever produce in this area of the demand curve. All right? Now, pay attention, because otherwise I'm going to get so many emails that I then always fail to answer. Number 1, you will get back your exam from Walter and Fiona once I walk out of here. You did well. The average is about the same as on the last midterm, which is not something you wanted to hear. The average grade out of 80 points, okay, so this is not percent, X bar was 61.38. It's about a 75. The median was 63. The minimum is 36. And the maximum is 80 points. One person has achieved what no person has ever achieved in the history of 106 before. It's gotten a perfect score on midterm 1 and 2. That's never happened, so I know who you are. You should come talk to me about graduate school. But many others of you should too, of course, but that's pretty impressive. So when I put my pen down now, you have 1 week to contest your grading with me. Do not ask the GSIs what they think. Should you contest or not, you contest to me in writing. You hand it to me by the end of lecture next Tuesday, and that's when the deadline ends. I have office hours from 3:30 to 5 today. I'm happy to talk to you about anything you want, including the exam. We'll post the answer key later this afternoon. So pay attention. The answer key is not in here, right? I don't want to hand out the answer key. Okay. Walter, do you want the beginning or the end of the alphabet? Beginning's good. So Walter has letters A for Apple through M for Max. Okay? Walter will be right there in that corner. Fiona has the rest of the exams. Where do you want to be? In this corner? Fiona will be right here. Thank you.